hurricanes, supervolcanoes. Sooner or later, nature's worst catastrophes, destroyers of civilizations, will be here.
We're talking about terawatts of energy.
Governments and scientists are now developing serious projects to do what was once unthinkable: control nature and save the Earth. Asteroid-blasting mirrors, hurricane-busting pumps, monitors that can predict a volcanic explosion months in advance. But can technology save us in time? Will we ever be able to prevent Armageddon? It's 4 a.m., sometime in the not-too-distant future. An astronomer has been up all night trying to make sense of his data. What looks like an asteroid 10 kilometers wide has suddenly appeared in the sky, closer to the Earth than the Moon. It's heading straight for us. Finally convinced, the astronomer contacts others in the sky-watching community. Soon, the whole world is aware. A killer rock, as large as the one responsible for wiping out the dinosaurs, is due to hit the Earth in a matter of hours. Could it happen? Somewhere, scientists agree, is a space rock destined for Earth.
The chances of a global disaster caused by an asteroid impact are certain. It will happen. The question is when, and that's always the hard part.
Astronaut Stan Love is also a planetary scientist and an expert on asteroid collisions. He's convinced we need to plan for planetary defense.
Impacts like the kind that we think wiped out the dinosaurs 65 million years ago happen on average once every 100 million years. We've got 35 million left, right? No. It could happen tomorrow. It could happen 200 million years from now.
Most of the millions of asteroids in the solar system lie harmlessly far away in a belt near Jupiter, circling the Sun. But an estimated 20,000 cross the Earth's orbit and are big enough to cause serious damage. So far, we've identified and tracked orbits for less than 1/10 of these potential hazards. Compared to planets and stars, asteroids are small, dark, and difficult to spot. Our warning time for an impending collision from a known asteroid will be years. But undetected asteroids could come upon us with little or no warning. Love has worked out just what will happen if we're unable to prevent the worst-case scenario.
A global disaster asteroid might be 6 miles across and moving at 12 miles per second. The speed of a rifle bullet is maybe 2/3 of a mile per second. So it's very big and it's coming very fast. The asteroid hits the surface of the Earth. It's going to dig down into the Earth about 20 miles deep before it finally comes to a halt, and that takes about 3 seconds. The heat melts the asteroid, it melts the target rock, it boils the asteroid, it boils the target rock, and that hot, molten, vaporized rock expands and explodes like a bomb. So it's like a buried charge going off.
The explosion creates a crater over 150 kilometers wide. Debris thrown up above the atmosphere re-enters and lands all around the Earth. In the aftermath of the strike, chemical reactions poison the atmosphere for years.
Whether or not human beings could survive, I think, is dicey. Even if the human species was not eradicated, 9/10 of the people in the world would die. It would be a disaster that, like nothing anyone has ever experienced in the history of humankind.
So is there anything we can do to prevent such a catastrophe? If a killer space rock is headed our way, calls for action are certain. The Hollywood option would be to use a nuclear explosion to destroy the asteroid. But would it work?
If you've seen any of the movies about asteroids and comets heading our way, the solution always seems to be to blast it out of the sky. Now that is the worst thing that you can do, because it won't actually change the path of the asteroid or comet. It will just mean that you have lots of bits of it and they're all heading your way. So it'll be like the Earth being hit by a shotgun blast rather than a single bullet.
The take-home message, don't believe everything you see in the movies. It doesn't always work that way.
Now, all too aware of our vulnerability, scientists are racing to find the best methods of diverting an asteroid.
Good morning.
Good morning, Jay.
Jay LaRoche believes we can take advantage of the long warning time and do the job with the power of the sun.
I brought this more or less ordinary rock here, but this is going to be a stand-in for our asteroid. We can't bring a real...
The geophysicist from Purdue University has a plan to launch mirrors into space and focus the sun's rays on the killer rock.
The plan of using solar mirrors works on the idea of using solar energy to turn the asteroid into a little rocket.
LaRoche's plan calls for huge mirrors and a lens to focus the power of the sun into a beam of destructive energy. In the vacuum of space, the tiny push created by the surface vapor would slowly move the asteroid into a new orbit.
Just like jumping out of a rowboat sends the rowboat the other direction, blasting off this material from the asteroid sends the asteroid in the other direction.
That's the theory, but how can it be tested here on Earth? The first step is to find out whether the sun's rays could be focused with enough intensity to melt a rock. LaRoche believes he's found a way. Standing in White Sands, New Mexico, is a solar furnace featuring a 12 by 11 meter bank of mirrors. It was built by the Army in the 1950s to simulate the extreme heat generated by a nuclear blast.
This is our heliostat.
LaRoche will use it as a stand-in for his mirrors in space. For the first time ever, he'll try to vaporize asteroid-like rocks.
Fire! Fire!
Whoa, look at it blast off.
Just flying up there.
Wow, those flakes are coming off like crazy.
Now, what do you think's causing that, Jay?
Well, I think those minerals are vaporizing. The water is blasting those chips out of there. Well, an asteroid that was made of that would be moving the other direction.
But LaRoche is not confident of success yet. There are many different kinds of asteroids, made of varied minerals. Will the solar rays work on them all?
That's it.
Now LaRoche moves to his toughest test. Basalt, 8 on the 10-point hardness scale. On Earth, basalt is a volcanic rock. But basalt asteroids may be shards of violent cosmic collisions. If a basalt asteroid hits the Earth, it will pack a powerful punch.
Those are individual impulses it's getting.
Yeah.
Boy, that's really coming apart.
Yeah, it really is.
That's it.
If an asteroid threatens, La Roche wants to blast his solar mirrors into orbit with plenty of advanced warning. It would have to reach the asteroid more than a year before the projected impact. With technology already tested by NASA for communication satellites, engineers will remotely deploy a thin circle of mirrored plastic sheet in space. Far larger than anything attempted before, the mirror will unfurl to a diameter of 750 meters. It's estimated that between 6 months and a year will be enough to nudge an asteroid off its collision course. This mission could save the Earth. But we don't just face one kind of threat from space rocks. We face many. We may need multiple plans of attack. Scientists estimate that there are at least 5,000 near-Earth asteroids large enough to cause serious damage, big enough to disrupt a continent. But some are not solid rock at all. These so-called rubble pile asteroids are loosely packed balls of space junk, bags of rock and sand held together purely by gravitational force. How do you deflect these asteroids?
An asteroid impact is preventable, and that is one of the most interesting things to me about this problem.
Astronaut Stan Love has a solution. Working from the International Space Station from the outside, Love has experienced firsthand how powerful the force of gravity can be in space. Now he wants to use that force to prevent disaster.
Everything in the universe pulls on everything else. So the idea is that we're going to make use of this universal law of gravitation.
Love calls it the gravity tractor, a spaceship designed to move an asteroid without making physical contact.
You just kind of sidle up next to it, you don't have to touch it, and it's rotating there underneath you with all its terrible rocks and boulders and dust piles.
Even though the tractor might be a small fraction of the size of the asteroid, it creates a tiny drag on the asteroid's orbit, slowing it down almost imperceptibly and altering its path.
We don't care if it's a bag of gravel, we don't care if it's a huge clump of hamsters floating through space. As long as they have mass, we can use gravity to hold onto them and pull them around.
A gravity tractor might save us from disaster, but only if it has enough time. A slight orbital change will only have a big effect if it happens many years before impact. And it's still possible that an uncharted asteroid or a dark comet that's burned off its glowing tail could arrive with very little warning, perhaps only a few months. What then? We'd be sitting ducks. Or would we?
That's a 1, high voltage on.
We're ready to go.
Laser on in 5 seconds.
NASA aerospace engineer Jonathan Campbell thinks we have only one hope should a comet or an asteroid appear with little warning.
And I sometimes like to call those bad rocks.
Today, he's at Kirtland Air Force Base in Albuquerque, testing the effect of a laser on comets and asteroids.
Everyone has goggles?
This is sort of like a kung fu approach as opposed to a sumo wrestler's approach.
Campbell is using a laser called the Edsel, the electrical discharge coaxial laser. A mix of colliding gases shoots out a beam of focused infrared light, landing a charge of 15,000 watts.
When the laser pulse arrives, just a micro-thin layer of the surface is turned into a gas.
Like the effects of the solar mirror,